In this video, we're going to learn how to add directed numbers. First, we'll start with a question involving adding together two positive numbers. +2 add +3. Pupils might be more used to seeing this written as 2 plus 3. When no symbol is used, we assume the number is positive. We only put the positive symbol when we're performing calculations that involve both positive and negative integers. It helps to avoid confusion. To answer this question, we'll only need to use our white +1 dot counters. +2 add +3. Altogether, we have 5 white dot counters representing a value of +5. Children often use concrete resources like these counters alongside pictorial representations like number lines. These are where integers are written horizontally on a line from smallest to the left and largest on the right. In the case of +2 add +3, they would start at +2 and then to show an addition of +3, they move 3 intervals to the right to get to +5. Adding a positive number to another positive number is really straightforward as it is just simple addition. When we add on a positive integer, the value will increase. Therefore, we always move to the right on a number line to show this. But how will this help us to know how to add negative and positive integers together? Let's look at this question. We're starting with a negative number and we're adding a positive. -3 add +4. We know on a number line when we add, we need to move to the right. So for this question, we're adding 4 positive ones. We'll need to start at -3 and move to the right 4 intervals to get to +1. We're doing the same method as we did before. It's just that we're starting with a negative number this time that's further to the left on the number line. Now we're going to answer the same question using our dots and tods. To represent a value of -3, we're going to use 3 black -1 tod counters. Now we need to add the value +4. So we're going to add 4 of our white +1 dot counters. We're able to make 3 sets of 0 pairs. When we remove these, we're left with 1 white dot counter representing a value of +1. So -3 add +4 is equal to +1. Let's look at another example that starts with a negative number and adds a positive number. -7 add +5. You may have already noticed that the answer to this question will result in a number below 0. We're going to represent the value of -7 by using 7 of our black -1 tod counters. Now we need to add the value of +5, so we're going to use 5 of our +1 white dot counters. We're able to make 5 sets of 0 pairs. When we remove these from the group, we can see that we're left with 2 black -1 tod counters with a value of -2. So -7 add +5 is equal to -2. We can check this using our number line to see if we get the same answer. We begin at -7, then we need to add +5. So to do this, we need to move 5 intervals to the right. We get to -2, so we do get the same result. -7 add +5 is equal to -2. We've just looked at how to add two positive numbers together and how to start with a negative number and add a positive number. But what if the question's the other way around? So this time we'll look at how to do a question which starts with a positive number and then adds a negative number. Here's our first question. +3 add -2. This is the same as 3 subtract 2. And I'm going to use a number line in our dots and tods to explain why. We know that when we add a positive, we move to the right on a number line, but this time we're adding on a negative. So what happens then? On a number line, when we add a negative, we need to move to the left. This question is asking us to start at +3 and add -2. So if we start at +3 and move 2 intervals to the left, the result is +1. This is the same as if we had 3 subtract 2. We can use our dots and tods to model this with concrete representations. We'll start by using 3 white +1 dot counters to represent the value of +3. Now we're going to add 2 black Todd counters to represent the value of -2. We're able to make 2 sets of 0 pairs, and when these are removed, we're left with 1 white dot counter with a value of +1. So +3 add -2 is equal to +1. Again, we get the same answer as we did on our number line. Let's look at another example. +5 add -3. We'll represent the value +5 using 5 white dot counters. Now we're going to represent the value -3 with 3 black Todd counters. We can see that we're able to make 3 sets of 0 pairs, and when we remove these, we are left with 2 white +1 dot counters with the value of +2. So we've solved the question, +5 add -3 is equal to +2. In the previous 2 questions, the answer was always a positive number, but sometimes when we begin with a positive and add a negative, the result can be less than 0. The next question is an example. +4 add -5. So let's represent +4 with our white dot counters. Now we have to add -5. So we'll use 5 black Todd counters. We're able to make 4 sets of 0 pairs, and when we remove these, we are left with 1 black -Todd counter with a value of -1. So +4 add -5 is equal to -1. Here's another quick one to try, again starting with the positive and subtracting a negative with a result which is below 0. For this question, we have +3 add -6. We have 3 white dot counters and 6 black Todd counters. We're able to make 3 sets of 0 pairs, and when these are removed, we're left with 3 black Todd counters with a value of -3. So +3 add -6 is equal to -3. So far in this video, we've looked at adding together 2 positive numbers and also adding positive and negative numbers together. But what happens when we need to add together 2 negative numbers? You might remember that when we add on a negative, we move to the left on a number line. So if we start with a negative number, we're just starting at a lower point on the number line, and we'll just move a given number of intervals to the left. So here's our next question. -3 add -2. As we have 2 negative numbers that we're adding together, we'll only be using our black Todd counters. -3 add -2. Altogether, we have 5 black Todd counters representing a value of -5. So -3 add -2 is equal to -5. Let's just recap what we've done so far with 4 quick examples. Here's one again where we're adding 2 positive numbers, so we're just going to use our white dot counters. +5 add +2. +5 add +2 is equal to +7. The next question is a negative add a positive. -2 add +5. We're able to make 2 sets of 0 pairs. When we remove these, we're left with 3 white dot counters. So -2 add +5 is equal to +3. Now let's try a positive number add a negative number. Positive 2 add negative 5. We're able to make two sets of 0 pairs. And when we remove these, we're left with 3 black Tods. So positive 2 add negative 5 is equal to negative 3. And the last one is adding two negative numbers together. So we're just going to use our black Tod counters. Negative 2 add negative 5. Altogether, we have a value of negative 7. Pupils may be able to quickly notice that they'll be able to predict how many 0 pairs there would be in a much quicker time than it would take to actually make them using dots and tods. They might be able to notice in a question like, for example, negative 15 add positive 20, they would have put down 15 black Tod counters and 20 white dot counters. They would have been able to make 15 sets of 0 pairs with 5 white dot counters remaining, giving them an answer of positive 5. It is at this point where pupils will be able to answer more questions involving adding directed numbers without needing to use dots and tods, or perhaps they could use them to check their answers. In the last part of this video, I'm going to show you a quick activity that the pupils could do so you can assess whether they have a really clear understanding of how to use dots and tods to add directed numbers. Simply arrange some dots and tods on a table. Then ask the pupils to tell you what value is represented. In this arrangement, we have 4 white dot counters and 5 black Tod counters. This represents a value of negative 1. This is because we're able to make some sets of 0 pairs. And when we make our 0 pairs and then remove them, we see that we're left with 1 black Tod counter representing a value of negative 1. Here's an example of a representation of a value of positive 2, as we're able to make two sets of 0 pairs, leaving us with 2 white dot counters, showing that it was representing a value of positive 2. A further way to challenge pupils would be to give them a number of your choice, either a positive or a negative integer that you would like them to represent using dots and tods. So for example, ask them to represent the value positive 3. The first way to do this would be to simply use 3 white 1 dot counters, representing a value of positive 3. Now challenge them to represent a value of positive 3, but this time they have to use both dots and tods. So here's one way of doing it. As quite often is the case when doing investigations, there is more than one way to solve a question. If we add 3 more white dot counters and then we place 3 black Tod counters, we can see that this now represents a value of positive 3, but we've used both dots and tods counters. To check, we can then make our 0 pairs, and we can see that when we remove these, we are left with 3 positive 1 white dot counters. Show me different ways to make the value negative 2. They perhaps may show one idea of just using 2 black Tod counters. Show me another way of using dots and tods to make a value of negative 2, but this time you need to use both dots and tods. This time the pupils may realise that in order to be left with a value of negative 2, they will need to have 2 more black Tod counters than white dot counters. So here is another representation of the value of negative 2. Activities like these are a really fun way for pupils to continue to practice using dots and tods to add directed numbers. It's also a good way for you to assess whether pupils are ready to move on to the next stage of subtracting directed numbers. This is what we're going to be looking at in our next video.